Okay, so this evening we're looking at the intermediate paper 2 from November 2017. We've pre-filled the front, so we're looking at getting pretty much question 9, get into and beyond question 9, and we're into the C and B grade questions. The additional formulae that is worth remembering: trig triangles, particularly important tonight. If they're going to come up anywhere, it'll be on a paper 2. Similarly with circles, circles would be a very common question on a paper 2. And then the other standard ones, the metric to imperial equivalences that we need to know, speed, distance, time. And another one which I haven't put on the other papers, but does come up every so often, is the relationship between density, mass and volume. So that's quite useful to know as well. I haven't put the fractions of an hour because on the calculator paper we're able to use our time button on the calculator, so if one of those comes up we'll be using that. Okay, so straight in. Calculate 8% of £3.25. So we're allowed to use our calculators. Calculator's got a percentage button on it. The only button that we haven't got in the calculator is an of button. There's no of button, but we know that that is what the times button does. So we can work that out by doing 8% of £3.25. So the percent button is shift open bracket. You have to put times in. So turn it into a decimal, 0.26. Now what's important here is that you are either going to write that like that, or you're going to write it like that. Okay, so you've got to make sure that you've got the units correct. Evaluate, that means work it out, find out the answer. Now on your calculator, the only thing you can't write there is the times. So we can put that whole thing on our calculator exactly as it is, except replacing that with a multiply. So 0.65 times 280, take away fraction 2 over 9 of is times 513. Press equals 68. So long as you're comfortable using your calculator, that's dead easy.
I worked out separately.
Did you get the same answer?
No.
So working that out separately, you would have worked out the 0.65 times 280, then 2 9ths of 513, then subtract them.
I didn't. I worked out the whole of 0.65, 200 and the fraction.
Yeah.
Get the answer and then times it by 500.
No.
It's
No. So it's either that bit and that bit separately, and then subtract them, but it isn't all of that and then times by 513.
So it's always...
Okay, but if you type it into your calculator does all the hard work for you, so safer. And then for part C, so same thing, we put that into our calculator, 3.5 squared, take away the square root of 8.6, so it looks exactly as it does on the page. And with this one, when we turn it into a decimal, we can see we've got a long string of numbers, and there's going to be a mark, there's an instruction there to give your answer to 2 decimal places. What I always suggest is before you round it, write down enough of what's on your calculator screen so the examiner knows you've actually done the right thing to that point. 4, 2, 4, 3, 4. So of those 2 marks, you're going to get 1. And then all you have to worry about is 2 decimal places. So for decimal places, you start counting after the decimal point. So the 3 is the first one, the 1 is the second. So my answer is either going to be 9.31 or 9.32. You look at the next one, it's more than 5, so it's closer to 9.32. Okay, marks for question 1 then. So there's a method mark for writing down how you're going to find the percentage, and then there's 2 marks, 1 mark for 0.26, and another mark if you've actually got the right units with it, so that you're clear that it's 26 pence, either written like that or like that. For part B, well, if we've used the calculator to get the right answer, it's just 3 marks. But if you broke it down, there'd be a mark if you correctly worked out that part, a mark if you correctly worked out that part, and then go on from there.
It was if you mess up.
Yeah. And then for part C, you've got 1 mark for the correct outcome from that calculation, and 1 mark if you've correctly rounded it to 2 decimal places. Question 2, time. So what is the difference between the following times? 7:30 on the 1st of November 2017 and 13:20 on the 3rd of November 2017. So this one is easiest figuring it out by counting on, whether you're going to count on with your fingers or work it out. So we've got 1st of November 7:30 to the 2nd of November 7:30 is 1 day, to the 3rd of December at 7:30 is 2 days, and then we're going to jump from 7:30 to 8:30 to 9:30 to 10:30 to 11:30, 12:30. So that's 1, 2, 3, 4, 5, 6 hours. Hang on, gone wrong there. 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. And then from 12:30 until 1:20 is another 50 minutes. There's no real easier way of dealing with that. But then when it comes to this part B, divide 16 hours 20 minutes by 5. That's where the calculator is really useful, with the time button, which is the one which looks like a load of full stops and commas. So we're going to do 15 time button, 20 time button, divided by 5. So 16 time button, 20, and then you've got to press it again. So you're saying 16 hours 20 minutes, divide by 5, and it does it straight for you, 3 hours and 16 minutes.
Wait, so how do you get 15 minutes on the top?
Going from 12:30
Yeah.
to 13:20 is another 50 minutes.
15.
Yeah. Okay, or if you go from 12:30 to 1:30, it's 60 minutes, but then you've got to go back 10 minutes because it's not a full hour. So with that one, what do we got? Question 2. So there's 2 marks basically for it all right, 1 mark if you get 2 parts of it right. And then for part B, again, so long as you know the secret of the time button, it's a really straightforward question, which is harder if you don't know that you can use that button. Question 3. A number is to be written on the blank card. The mode and the median of all 7 numbers are both the same. Find one possible number that can be written on the blank card. Well, if we're working with median, we know we've got to put them in order of size. So the smallest is 5, then 9, then 11, then 18, then 20, then 23. And we've got one more card to put in there to make the median and the mode the same. So the median is going to be in the middle, so it means I've got to put the number there. So to make the median and the mode the same, I'm either going to have 11 or 18. Either one of those numbers will give me a mode. So if I chose 11, it's got a mode of 11 and a median of 11. If I chose 18, the mode would be 18 and the median would be 18. So it doesn't matter which of those two, but you only have to choose one of them. You don't have to say both. One extra number is added to the following list of 3 numbers. The mean of the new list of 4 numbers is 1 less than the mean of the original 3 numbers. So to find the mean, we've got to find the total. So we've got 21, 27. And for the mean, we've got to divide that by 3, because there are 3 numbers. So the mean is 9. We're going to add one more number to that list, and it's going to make the new mean 8. So the new mean is 8, but there are now 4 numbers. So I can now work out what the new total is going to be. So it'd be 32, yeah? 4 times 8. So the total of the 3 numbers is 27. The total of the 4 numbers is 32. So the extra number that's been added is the difference between those 2 totals. 5. Okay, marks for that. So just 1 mark for the site of 11 or 18. And then for this one, there's 1 mark for working out the original mean. There's 1 mark for working out that means the new mean is 1 less, which is 8. There's 1 mark for working out the new total is 32. And there's 1 mark for the final answer. So it's really important to remember that if they give you the mean and however many bits of data there are, you can find the new total. Question 4, bearings. How would the direction due west be written as a 3-figure bearing? So you need to know positions on the compass: north, south, east, west. Bearings are measured from 0 at north in that direction. So you're going through 3 quarter turns, 3 nines, 27, 270. There are 360 degrees in a full turn. A pointer facing due south is spun clockwise through 3 3/4 full turns. In which direction will the pointer now face? Well, the full turns doesn't make any difference because you're back at the start. So if you start at facing south and you go through 3 full turns, you're still facing south, and then you're going through a 3/4 full turn, 1 quarter, 2 quarters, 3 quarters. So you'll be facing east.
So for example, you started out west, would it always be east?
No, if you started facing...
Oh, it says due west. Oh, never mind.
Yeah. No, that was for part A, due west. Part B, due south.
Okay.
Yeah. Part C. What is the bearing of point P from point A? Circle your answer. So you're standing at A, north is 0, and you're turning until you're looking at P. So you've gone through 180 degrees north to south, plus another 40, 220. So just 1 mark for each of those. Question 5. Calculate the area of the trapezium shown below. You must give the units of your answer. So there's one of those marks, even if you get the maths wrong, would be for writing the units of area with centimetres. Okay, and this is a trapezium, and we know that this is one of the few formulas that they actually give you. Okay, So the area of the trapezium is going to be a half, open bracket, A plus B, where A and B are the two parallel sides. So that's going to be the 8.2 plus the 17.3. And then close bracket H, well, I've got to put a times in for that closed bracket, and then H is the perpendicular distance, the right angle distance between the two parallel sides. And I can put that on my calculator exactly as I've written it. So fraction for the half, open bracket, 8.2 plus 17.3 close bracket. Then the only bit of work I've got to do is to put that times in myself, and then the calculator is doing all of the rest of the work for us. So it's 119.85. That's not going to earn me full marks because the unit of area with centimetres is centimetres squared. So there's 1 mark there for putting everything into the formula correctly, 1 mark for 119.85, and a unit mark for the centimetres squared. And if you'd have just made, if you thought I can't find the area of that, I'm just going to write down 1,000 centimetres squared, you'd get the unit mark, even though you've written gibberish.
So you'll get 2.
So you get 1 mark if you wrote 1,000 down, because the method's wrong. I've just chosen a number to stick centimetres squared on the end of. Question 6. Express 54 as a percentage of 129. So where kids get in a mess here is that they see the word of and they think I've got to times by 129. If you're writing 54 as a percentage of 129,
So you put 54 as a percentage.
no, it means you've got 54 out of 129. To turn it into a percentage, you times it by 100. So if you're writing one thing as a percentage of another, you write it as a fraction, 54 out of 129, and then multiply it by 100. And calculate the fraction button, 54, 129 times 100. So it's 41 point, and here again, there's an instruction that they want you to round it to the nearest whole number. So first of all, write down beyond that so the examiner can see you've done the maths right there, and then to the nearest whole number, it's either going to be 41 or 42. It's closer to 42 because of that 8. Share 25.8 kilos in the ratio of 5 to 1. So with ratio, you've got to be clear as to whether or not that is the total amount or whether it's one of the parts.
It's a total.
With this one, it's the total amount. So I've got to divide that by 6 parts. So 25.8 divided by 6 is 4.3. So then 1 part is 5 lots of 4.3. So you times it by 5. And the 1 part is going to be 4.3. So marks for this. 1 mark for 54 out of 129 times 100. So just writing down your method. 1 mark if you've got 41.86 and you haven't rounded it. And another mark if you've done what you're told and rounded it to the nearest whole number. And then here, 1 mark for the method of doing 25.8 divided by 6, and 1 mark for correctly writing down the 2 parts. Question 7, a little bit of probability. The following cards spell out the name astragon lice. In an experiment, the cards are turned face down and rearranged. A card is selected at random and the letter on the card is recorded. The experiment is carried out 325 times. How many times would you expect the letter Y to be recorded? So you'd work out the probability of it happening once, which will be 1, 2, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. And then you'd multiply that by however many times it was being repeated. So you'd be timesing up by 325. So 2 over 13 times 325. You'd expect it to happen 50 times. So 1 mark there for just writing down 2 out of 13, 1 mark for the method of multiplying it by 325, and 1 mark for the right answer. Question 8. So this is the OCW question, and it's a circle and its area. So this is now where we're getting into the D into C standard of questions. So calculate the area of the shaded region. You must show all your working. So what are they telling us? AB is the diameter of a circle centre O with radius OA equals 4.2. So the radius is 4.2. I'm thinking area circle radius. I'm thinking area is pi r squared. So I'm probably going to be using that. ABCD is a square. ABCD is a square. So the diameter of the circle is going to be the length of the sides of the square. Yeah. Calculate the area of the shaded region. So the shaded region is a square which has had half a circle chopped out of it. So if I can work out the area of the square and work out the area of the semicircle and take them away, I'm in business. But this is the question where I'm also communicating what I'm doing. So, side of square equals diameter of circle equals 4.2 times 2, which is 8.4. So I know that this square has got a side of 8.4. So the area of the square will be 8.4 times 8.4. $70.56. And the units will be centimeters squared. The units of the diameter will be centimeters, because I'm conscious that to get those OCW marks I need to be consistent with my units, so I'm putting them in. Now out of that square I need to cut the area of half the circle. So area of circle is pi r squared, which is pi times the radius is the distance from the centre out, 4.2 squared. So shift times 10 gives me the pi times 4.2 squared. So that's going to be 55 point, and because that's gone to 2 decimal places, I'll take this to 2 decimal places as well. So that's going to be 55.42. So the area of the semicircle, which is this bit, would be half of that. So 55.42 divided by 2, 27.71. So the shaded region would be the area of the square, if it was all there, which is 70.56. Take away the area of the semicircle. So 42.85 centimeters squared. So, marks for that. There's a method mark for seeing pi r squared, with r being 4.2 squared, all going straight to the dividing it by 2, and then an answer mark for the 27.7. Then there's a mark for seeing the area of the square. There's a mark for seeing there's a mark for the side of the square being 8.4. There's a mark for the area of the square being 70.56. The method and the accuracy are for the semicircle part, and then there's a final mark for the 42.85, which is the area of the shaded bit. Then you've got your OCW, 1 mark for just making it clear what you're doing, and 1 mark for being consistent with your units. That's question 8. Question 9 is the last of the foundation overlap. So ABC is an isosceles triangle with AB equal to AC. Calculate the value of y. So they like these geometric equation things. Often with triangles, but sometimes with quadrilaterals. If it's a quadrilateral, I know that all 3 of those angles will add up to 360. In a triangle, I know that all 3 of them add up to 180. But that doesn't help me because I got x's and y's. What does help me here is because it's isosceles, I know that the 2 angles at the bottom of the equal sides are the same. So because it's isosceles, I know that that angle, 4x take 3, must equal this angle. So it forms an equation for me. So this is an equation. It's a multi-step one because I've got x's on both sides of the equation and I've got numbers on both sides. So the first thing I'm going to do is get rid of that x from the right-hand side of the equation. It's a plus x there, which means I've got to take x off. If I take x off there, I've got to take it off the other side as well. So that leaves me on the left-hand side, 4x take away x is 3x. That take 3 is still there, I haven't done anything with it. And on the right-hand side, the x's have gone, and I'm just left with 48. Then I'm going to deal with the take 3. The opposite of taking 3 is adding 3. If I do it to one side, I have to do it to the other, which means I end up with 3x equals 51. To get the x on its own, I'm going to divide by 3. So 51 divided by 3, 70. So does that answer the question? No, because the question wants to know what the value of y is. But if I know x is 17, I know that that angle is 48 plus 17. So I know that that angle is 65 degrees. I know that that angle and that angle are the same because they're isosceles. So it means I'm going to work that out. I know that that is 65 as well. They've got to add it to 180. Those two add up to 130. So y is 50. Okay, so marks for that. 1 mark for forming the equation. So 4x minus 3 equals x plus 48. 1 mark for getting it down to 3x is 51. And 1 mark for x is 17. There's 1 mark then for showing that the angle is 65. And then a method mark for figuring out that those two add up to 130, so that one must be 50. 1, 2, 3, 4, 5, 6. So usually those questions carry quite a few marks, and once you build the equation, it's relatively straightforward from there. Okay, so that takes us into the CB part of the paper.